Okay, so in this lesson, we'll be proving geometric relationships. These are things you should be able to do by the end of the lesson. You should be able to prove geometric relationships. You should be able to prove theorems about lines and angles, and you should be able to apply proofs to real-life situations. So here is my first example. I am given AC equals AB plus, it should be AB plus AB, and I want to prove that AB equals BC. Then I want to go ahead and solve this. So what I always do when I have a proof is I start off with two columns. I have my statements and my reasons. The AC equals AB plus AB is what the problem gives me. So that literally goes in my first statement spot, and my first reason is always given. So I have that. Then what I also know is, because this is a segment, and we've talked about the segment addition postulate on another video, is that AB plus BC equals AC. And that's by the segment addition postulate. So here you can start using those things you learned on the other notes about angles and addition postulates. So we have that. Then what I can do is I can use the transitive property of equality. This means, notice how I have the AC up here and I have the AC down here. What I did was I just simply replaced AB plus BC for AC and set it equal to AB plus AB because they equal the same thing. Then what I can do is, because I have AB on the same, or on both sides, I can remove it by subtraction, and then I end up with AB equals BC. So my last reason is the subtraction property of equality. My last reason of a proof should never be proof. Okay, I noticed that a lot when I was looking through the assignments. Okay. This next proof is telling me measure of angle 1 equals the same as measure of angle 3. I want to prove that EBA is the same as the measure of CBD. So I'm looking at this angle right here. I really hope you can see my cursor. And this angle right here. Okay. So my first statement is always what they gave me. So measure of angle 1 equals measure of angle 3. And that was given to me. Then I want to say that the measure of angle EBA, because I'm trying to connect to this bottom piece. So what I want to see is, I want to see how I can get there. I first need to talk about how measure of angle EBA is made up of. It equals angle 2 plus angle 3 by the angle addition postulate. Okay. So now that I have how angle EBA is made up, I can use what I was given to replace it, the angle 3 with angle 1. Remember, this is substitution when I'm replacing. So measure of angle 2 plus measure of angle 1 still equals EBA, and this time I replaced it, substitution property of equality. Think about it. When a teacher's not here, they're replaced by a substitute. So when you're replacing something, it's substitution. Okay. Then I just rewrote the order. So I used the commutative property of addition. Remember, order is commutative because, just like driving cars to work, the order you go in on the freeway doesn't matter. It just matters that you get to work. Okay. Then I have measure of angle 1 equal, or plus measure of angle 2 equals the measure of angle CBD. This is by the angle addition postulate. So I'm ignoring what I have for EBA for right now, and I'm just looking at this angle up in the top to see what it was composed of. And then in this instance, I want to get rid of the measure of angle 1 plus the measure of angle 2 and join the EBA and CBD together by the transitive property of equality. So when I'm joining two equations together, I'm linking them together like cars on a train, which is how I know it's the transitive property. Okay. My next proof is proving the symmetric property of congruence. This one is telling line segment LM is congruent to NP. I need to prove that NP is congruent to LM. So I'm going to start off with my statements and reasons. My first statement is always what they gave me. LM is congruent to NP, that was given. Then I know that the actual line segments, LM and NP, when it doesn't have a line above it, it's referring to their length. So I know that these two are congruent because that's the definition of congruent. Then I know NP equals LN because that's the symmetric property of equality. I just flip the sides, like looking in the mirror, it's a reflection of what it was. Okay. Then I have that the line NP is congruent to the line LN by the definition of congruent segments. Okay. This next proof, I have that given angle 1 and angle 2 are right angles, prove that the two angles are congruent. So what I want to do here is I want to start off with my statements and reasons. I have that angle 1 and angle 2 are right angles. That was given to me. Then I know that because they are right angles, their measures have to be 90 degrees. So that's my next slide. The measure of angle 1 is 90 degrees. The measure of angle 2 is also 90 degrees because this is definition of right angles. That's what it means to be a right angle. You have a measure of 90 degrees. Okay, now that I have that the two angles equal the same degree, I can link them together like cars on a train. And I have measure of angle 1 equals measure of angle 2. This is by the transitive property of equality. And when I know the measures are equal, I know that that means they are congruent because congruent means they have the same measure. So I have angle 1 is congruent to angle 2, and this is by the definition of congruent angles. Okay, this one I am proving the vertical angles congruence theorem. I have that angle 5 and angle 7 are vertical angles. So if I look at this airport picture, I can see that 5 and 7 are across from each other. I need to prove that 5 and 7 are congruent. So I'm going to start off with my statements and my reasons. I have the given that angle 5 and angle 7 are vertical angles. Then I have that angles 5 and angle 6 are a linear pair. So 5 and 6 are together on this map to make a straight line. And 6 and 7 are also together to make a straight line. They have to be touching to be a linear pair. Okay. Then I have angle 5 and angle 6 are supplementary, and angle 6 and angle 7 are supplementary. This is by the linear pair postulate. So going back to the notes we did last week, remember that anything that's a linear pair is always supplementary. Okay. Next piece is going into what it actually means to be supplementary. Remember, supplementary adds to 180. So I have the measure of angle 5 plus the measure of angle 6 equals 180 degrees, and the measure of angle 6 plus the measure of angle 7 equals 180 degrees. This is by the definition of supplementary angles. So literally saying what it means to be supplementary. Then notice I have them both equaling 180 degrees. So I'm going to link those two ideas together like cars on a train. I have measure of angle 5 plus the measure of angle 6 equals the measure of angle 6 plus measure of angle 7. This is by the transitive property of equality. Then I can remove measure of angle 6 from both sides because it appears on both. When I do that, remember it's by the subtraction property of equality. And then finally, I need to prove that my two angles are congruent. So I know that the measures are equal. So to be congruent, that is the definition. I have angle 5 is congruent to angle 7 by definition of congruent angles.